Okay, so we have this going. And I'll start the recording here. Good evening, everyone. Welcome to the Silicon Valley chapter of IEEE Computer Society. I am the chapter chair, Vishnu Pendyala. Ours is the largest chapter in the Silicon Valley section of IEEE, with over 4,000 subscribers in our mailing list and a strong following of over 12,400 on Twitter alone. We are uniquely positioned by the virtue of our location and available expertise. So the agenda for today is simple. We want to start with our annual award ceremony, followed by the talk by the award recipient, Shubhi Asthana, who is here in the room today. She'll be talking on artificial intelligence for order management process. That followed by Jyotika Athavale, who will be talking on safety of autonomous vehicles, followed by the vote of thanks. So before we begin our proceedings, just wanted to let everyone know that we are always looking for volunteers. So we volunteers can help with our magazine editorial support, our social media and publicity efforts, student chapter and school liaison. And we organized 2 conferences this year. The chapter organized 2 conferences. So we also look for help with the conference organizations. So this year it was virtual, but maybe next year it will be in person. So you'll have the opportunity to network and stuff like that. And any other way you can contribute, you're welcome. Please email us if you're interested. Okay, the award winner for today is Shubhi Asthana. I will read the nomination by Qatar Al-Maghrawi, who is a principal research staff member, artificial intelligence engineering with the IBM Research, Yorktown. She is Shubhi's colleague. 1 second. I'm showing the wrong. So in the words of Dr. Maghrawi, Shubhi Asthana, as a rising star in the field of services computing and service sciences, Shubhi has demonstrated outstanding, impactful, and sustained contributions towards research and leadership in the field of service science and analytics, which is an important and strategic area in the tech industry. And to list some of her remarkable words and outstanding achievements, Shubhi Asthana has been the research technical lead of the Service Analytics Project, GPO, at IBM Research. It's a global purchase order tool. The project has core business and research teams, and Shubhi has been leading the research team, effectively demonstrating leadership and impactful contribution in handling services projects. She brings cutting-edge innovations to these projects and delivers them to the business. In this particular project, Shubhi has led the development of a risk analytics system, which analyzes the purchase orders for a customer, looks at the patterns of invoices billed to the customers, and detects when will the customers exhaust their PO funds. Purchase orders are documents provided by our customers detailing the services we would provide them to document an agreement and commitment to pay the invoice. Shubhi Asthana led the development team and translated the built research technology into a product prototype within a few months. She effectively used her soft skills to interact with the business stakeholders and communicate the results back to business. She also published the innovative results and algorithms in top-tier conferences like NeurIPS, Informes, KDD, IEEE Big Data, and patented the novel ideas. Overall, she has demonstrated technical leadership as well as strong communication and project management skills, delivering impactful solutions to the business, which resulted in more than $8.42 million of savings in cost and labor savings. As well as research innovations that have been shared with the services research community through publications and technical conference presentations, she makes an outstanding leader. In recent years, Shubhi has worked on building data analytics tools that are critical in the deal bidding process for IBM Global Technology Services, and to help GTS, which stands for Global Technology Services within IBM, improve deal win rate. Shubhi led the research and development team to invent the service tools that leverage novel analytics and operations research methods. Shubhi developed a top-down costing tool that consists of a prescriptive analytics data mining engine that uses historical deals and market data to calculate costs with minimal user input. The tools have been deployed to GTS teams and have resulted in significant improvement in win rate with realized revenue increase of nearly $350 million US. The journal paper, Analytics and Operations Research, increases win rates for IBM's information technology service deals, was published in the Informs Journal on Applied Analytics, and it was honored as an Edelman Laureate Award finalist. This project, led by Shubhi, received IBM Corporate Award, the highest honor for technology development in IBM, for its immense innovation and business impact in 2020. In addition, Shubhi received Outstanding Technical Achievement Award in 2021, 2019, and 2018, respectively, for her contributions to research and development of key functions. Shubhi's innovative work yielded to IEEE Senior Member Elevation in 2022 with more than 15 publications in top-tier research conferences and meetups, such as NeurIPS, IEEE SCC, IEEE SOLI, ICSOC, IEEE Big Data, and Informs. Some of her work was also published as patent disclosures and filed by IBM. Her patents range in topics like services research, optimization methods for handling services data, building innovative algorithms around peer-based models, and performance-related algorithms. Most of her patents are of high value to IBM and to the research community. In addition to her technical excellence in services computing, she has volunteered her invaluable time and tirelessly worked to support women in services. For example, she co-organized the 2021 IEEE Women in Services Computing Symposia, abbreviated WISC, co-located with IEEE Services. She is currently serving as a General Program Chair for WISC 2022. She presented invited talks at several conferences and workshops, such as IEEE Women in Services Computing, in 2018, 19, and 20, and helped co-organize the NeurIPS ML for HC workshop, which is machine learning for health. She has been passionate about helping women early in their careers and mentoring young women researchers regularly. Also, she pioneered a new tech column in the city newspaper that introduced tech terms in easy language to non-technical women readers. For this, she was recognized at the Watermark Conference 2020. Shubhi has been recognized with internal as well as external research and industry awards in numerous occasions. Internally, she has received the IBM Corporate Award 2020 for the business impact to IBM. For her exemplary technical achievements, she was awarded thrice, 2021, 2019, 2018, the IBM Outstanding Technical Achievements Award. It's abbreviated OTAA, and it's the highest technical accomplishment award at IBM. Externally, her projects received the Franz Edelman Award for Achievement in Advanced Analytics, Operations Research and Management Science for 2019, as well as first place for the 2018 ISSIP Excellence in Service Innovation Award. She also received the Rising Star of the Year by Women Tech Global Conference 2020 for her technical contributions and innovations. Shubhi was amongst the 2021 Silicon Valley Business Journal's 40 Under 40. Lastly, she was recently awarded the 2021 Women of Color Technology Rising Award. Shubhi is an accomplished researcher and an amazing role model for other women. So today's talk that she is going to deliver to all of us is on transforming the order management process using neural networks and risk modeling. The abstract is the transactions of goods and services between large businesses are often driven by contracts and orders. Based on usage of services, invoices are billed to the customer who settle them. Enterprise service provider process thousands of orders every year, and it takes considerable manual effort to process them. The invoices billed data is not always maintained in the same system as orders, and it takes effort to match them. Sometimes the invoices may get into a dispute due to over-exhaustion of allocated funds or may be billed to an expired order. Hence, managing the billing of order is a huge undertaking with increased cost. To address these challenges, we developed an order management workflow system that transforms the overall orders process to increase their renewals and decrease disputes. It comprises of two components. The first component is an automated order-invoice model and a risk analytics model that evaluates the contracts and orders against the invoices billed to the customer. The output is a ranking of orders based on customer portfolio, risk level, as well as market trends in usage services. Shubhi is going to illustrate their approach with some promising results on data of one of the world's largest IT service providers. So without much ado, let's welcome Shubhi Asthana to first deliver the talk and then receive the award. Yeah, sure.
Right. I hope everybody can hear me. So thank you so much, Dr. Vishnu, and thank you so much, IEEE Computer Society, the Santa Clara Valley chapter, for bestowing me with this honor. I'm honored to be part of the IEEE GHTC and to be able to talk on my work at this conference. So I'm definitely under more pressure now, but let's see. Please do let me know if you have any questions during my talk. So A short bio of myself. I've been here at IBM for a few years. I've worked on a variety of solutions. I started with working on sales solutioning using machine learning, and now I've progressed to financial services. So let me give you an overview of what I'm working on. Um, the transactions of goods and services between enterprise organizations can happen in two ways. Either you have a fixed contract, a fixed amount set up at the beginning of the contract where you say, this is what we are going to be delivering to the client. These are the services for this much amount with this kind of billing and settlement terms and conditions. Or the second way of delivering services is using pay as you go. Usually in enterprise organizations, when they handle per contracts which is more fixed around purchase orders, they have to be fixed with the billing services. So if I say that I want to handle I want to be able to provide these number of services to our clients, I want to be able to provide them with the purchasing, with the power of how the purchasing process looks like and how the renewal looks like. So this all system to handle is typically called as the order management system. Now, the order management system is a very complex process because when it comes to enterprise organizations, different departments are handling the sale of their services in different systems and data warehouses. The billing and the accounting system may also be handled separately, as well as the customer support. So, as you can see from this small picture, here are the different departments that are handling all the aspects of the order management. It could be what are the purchase order files, the investment, the sales, the customer's portfolio files, the accounts payable, which is handling the billing and settlement, etc. Okay. What are the challenges that we face? One of the challenges is the lack of governance of the data, because the business process might be pushed into the company or the organization a few years ago. During the years, different departments start adapting different methods of of implementing the same business process. For example, they may forego some of the intermediate processes in between, or they may start using different terminologies for the same terms. In our own organization, we realized that the term contracts was interchangeable with the word transactions, and it was also interchangeable with negotiation or a deal settlement. Moreover, the second challenge that we found was lack of manual monitoring and maintenance. Because the different departments handle the same purchase order data, right from signing the deal to delivering the services to what was the client billed and what did the client settle, there is lack of flow, end-to-end flow of the data of how the purchase order is progressing. Um, Moreover, the engage support, which is the customer support for that purchase order, may not be in sync with the different departments. Hence, we have to ensure that the data is updated. Even if it's updated manually, it is updated by the different systems and is able to talk to each other. So in this case, we have a customer who speaks to the sales department and asks for certain products and services. The billing department ensures that the billing is done on time. The purchase order department manages the purchase orders. The support department ensures that any grievances that are raised by the customer are managed. And also, the delivery department is ensuring that the invoices are being settled on time and that they should continue delivering these services. So, since we realized that there was a lack in the end-to-end flow, we wanted to have an efficient means of managing this data, which included the large number of invoices and the surrounding data. Not just the purchase orders, but the customer portfolio, the customer support, the grievances that they have, to ensure that we are able to renew our orders on time, and also we are not stuck with cash flow because of disputes that could occur because of the grievances that are not addressed. So, so as you can see in the existing order management flow, we realize that there are too many stakeholders which are involved: the customer representative, the delivery team, the purchase order management, the invoice management, and the support team. And this is how there were different departments who were talking to each other, and all the actors in this entire system may not have full visibility to the flow. So what were the likely outcomes that we could have done, that we could have achieved using any of the methods that we had? We wanted to ensure that we have visibility in the end-to-end process, to show more customer profiling. So if the customer tries to reach out to us to buy more services, we do have the knowledge of how we are dealing with the customer historically and how is the customer settling those data. A dashboard to be able to see those per orders that have to be addressed immediately by us, and to automate the renewal process. So we looked at the existing state of the art. This is not a problem just in the financial services industry, but there are cases in other industries where this has been done, addressed in different ways. But what we realized that we needed to do was to focus not just, we realized there was focus on the trends of usage of services, but not a focus on integrating the surrounding analytics that came with it, like what is the risk of that purchase order, or what is the customer portfolio surrounding it. And we also wanted to get what is the we wanted to be able to map two different data sets, or two different data warehouses. So if a purchase order data and a invoice data are maintained separately in data warehouses, how can we correlate the features between them and understand how the data can be how can we use the feature engineering to find a connection between the two data warehouses, so we can build the end-to-end flow process. And this we wanted to bring it out in a more generic way, so that this automated matching of data between data warehouses can be extended to other data warehouses too. So we could extend it to, say, contracts to invoices matching also. So here is a complicated methodology flowchart, which I would rather skip to go to the 3 steps that we did. What we did was, first we did the usual pre-processing the data, understanding what is the structured data, what kind of key labels were defined for the data, the purchase order data, the invoices data, the customer data, etc., and ensure that we have enough information to even process the purchase order. For the data which had incomplete labels, we perform text mining. We use the system which is the generic IBM NLP method, the tool that is used to parse the unstructured text, build entity key relationships, and pair them up with the appropriate labels. Using the structured data, we performed a Pearson correlation coefficient analysis to find which are the highly correlated features between two various data sets. And then we used a deep neural network. Now, this is something which is, this is the model which is, we are still modeling, we're still like fine tuning in process. So I haven't put too many details about it. But using the deep neural network, we realized that we have 2 million invoices currently, and around 11,000 purchase orders. We want to be able to trim down the invoices that match up to a purchase order without knowing the purchase order ID or the details of the purchase order. So this required surrounding analytics that a deep neural network can do, which takes into account other factors like the country or the client to which we are catering to, the sub services that are being provided. And using that, we trim down and cluster the invoices and then pair them up with the purchase orders that could potentially be matching towards it. Next, we built the most key aspect of our algorithm, which was doing the time series forecasting and risk modeling. Now, we want to be able to not just estimate how much the invoices we expect. Say, I have a purchase order for 12 months from January to December of 2022 of $12,000. And I'm expecting that I will be billing the customer $1,000 every month, and that the customer would be utilizing that much amount every month. However, the customer does not. We see that he's overutilizing the services in the first few months. So we do realize that midway of the purchase order by June, July, he will be out of purchase order funds and will raise a dispute with us, which would cause a cash flow impact. What we do is we use the trend of invoices in the first few billing cycles to be able to estimate when we would run out of funds and raise the risk of a purchase order accordingly. So if I do realize that by the second invoice cycle or by the next invoice cycle, we will be out of purchase order funds because the customer is overutilizing the services, we ask for the purchase order to be renewed proactively instead of waiting for it to expire and then react to it after it has expired. So this we did using the open source model by Facebook, which is the profit model, to analyze this trend in invoices and forecast the usage of services. So we could get what the expected amount of purchase order looks like. And from there, we got the risk factor of the invoice. So we categorize the risk as overbilled, high risk, medium risk, and a low risk, depending on how many number of invoices more can the purchase order cover. So basically, the risk analytics model was giving me a snapshot of how the purchase order is functioning and how it is functioning every 24 hours. And that snapshot was really important because I don't want my team of 8 members sifting through 11,000 purchase orders every week, trying to find out who are the customers they need to chase. So we could trim down that by around 5% to around, say, 100 to 200 purchase orders that were of high risk and which needed attention from us, where we had to either raise a dispute with them or we would reach out to them to renew the purchase order immediately so that does not create an issue with us. We used other features in our models too for this, like the customer features, like what geography market we were looking into, what were the PO features, what was the PO amount left, the validity, and our other derived features to come up with actionable and non-actionable items that could be clustered together. So this part of it was handled through the reinforcement learning. What we did was first we calculated how was the purchase order performing. This snapshot again was taken almost at the start of every week. We're looking into what is the risk of a purchase order. How is the customer portfolio? Are we looking into an enterprise customer? Is this a new customer or an old customer? How has the purchase order performed previously with the customer? Has it run into disputes before? Are we going to see repeated issues with them? Or have they reached out to us through any communication techniques like emails, or they've reached out to a representative and mentioned that we would be renewing this purchase order on time? So some of the data may not be already captured by the structured data we are receiving. Using that, we get the PO performance, and we are able to convert that into what are the set of actions we want to take and how the set of actions will impact the PO performance. That leads us to the reward function. We want the reward function to be able to showcase how the PO performance would change and utilize that to come up with our next steps. If there is a positive change in reward performance, that means our action items will help with the PO performance. We would provide our recommendations on what are the actionable insights to take place, like reach out to the customers, enable that the PO does get renewed over on time, and non-actionable insights like how is a certain department working, like say EMEA. How is the cloud services teams working? Are the purchase orders running always on high risk, or we are having less number of disputes in a certain geographical region versus another, etc. So this was very helpful from the management perspective. So we deployed this tool in phases since last year. This is how the snapshot of the tool look like overall. Um, this is a snapshot of a sample risk analytics that was shown, and a prediction and actual forecast of how the invoices trend would look like. So we were able to train it initially with 4,500 purchase orders when we started last year. We raised it up to 11,000 purchase orders by the as of last week, and we were able to translate the savings due to this risk analytics and automated PO invoice matching that we could do. We saved up to more than we could have substantial revenue impact, which uh, is understandable from enterprise organization point of view. So concluding, we were able to avoid a lot of disputes because of the risk analytics that was shown. We saved a lot of squad time. So we saved when we were calculating, estimating how much is our tool helpful to the financial system who looks into disputes. We saw that in 8 months, we were saving 14,000 hours of around 8 subject matter experts, which was equivalent to a good, again, to a good substantial revenue impact or savings with this. And so, and we had the human in the loop. We had the SMEs who were looking into our data mapping and risk modeling to ensure and providing us feedback to ensure that we were basing our performance correctly. So our key takeaways were that we provide better visibility into the order management process. We are able to do customer profiling to provide risk insights and to show high quality order and invoice data. And more essentially, what we realized was that this is a framework that should not just be restricted to purchase orders and invoices. This is an issue not just in the financial services industry, but in other industries too. Hence, we have started working on an insourcing framework so that we can extend our work to other departments also. And lately, we have started working on an open source framework model where we can extend our work into an open source work where the risk analytics aspect of our work can be easily extended uh, to any other application as required. So I would have more details about it in the future. But thank you so much for listening. And if there's time, I would be happy to take any questions.
So any questions from anyone? Okay, there's a question here. So
Thank you, great presentations. Thank you for that. So I have two questions. One is you showed an actual versus the actual versus the prediction.
Yes.
So when you see on the other side, I don't know what was the prediction model.
Yeah, as you can see, our prediction model was looking at the trend and usage of services, but we realized that sometimes there is our prediction is based on the historic trend of usage, but sometimes an actual usage of services is sudden and is not explainable. For example, there was no key explanation as to why the usage of services for this customer suddenly dropped. So at that point of time, yes, we did have an error in the prediction of our services, and that does raise a key point of, how reliable is this risk modeling if you're taking into account only the historic trend. So this is where we take into account the customer portfolio, and if the customer is an old customer, how have the other purchase orders in the past performed. But there is this key aspect that there can be a sudden drop or a sudden raise in usage that cannot be predicted always.
So proportional to the data assessment.
Yes.
And the second and more immediate point, what is the programming language they use to
So we built a prototype for in Python that was done in 2 months using the simple scikit-learn libraries. And then our model, our application is a web-based application using Java, and it has the risk modeling Python framework and the neural network models which are running using Python. Yeah, we've used this the open source libraries, and for time series forecasting, we use the profit model.
any other questions from anyone? Yeah, I think there's a question from Siva.
Not a relevant question, but can you take this and use in other areas of, the personal prediction of cash flow? Is there any other usage?
Yes, so we extended this to contracts and invoices data too. And we are now building the insourcing framework, which is basically instead of open sourcing our work directly to the world, we are opening up our work within IBM. So we want to be able to use it in the banking division. We want them to be able to map their customer data with the negotiations and sales deals that come through. So since their data sets are also very vast and the revenue impact is large, we think our risk analytics model would be very useful there.
Okay, any other questions? If not, let us thank Shubhi and
Thank you.
Shubhi creates history. Shubhi creates history for the chapter by being the first Industry Rising Star Award for 2022, presented to Shubhi Asthana.
Thank you so much.
Thank you. Thanks for the talk. Okay, we next move on to the next talk of the session of the event. Let me. Which is safety for autonomous vehicles. So this talk will be delivered by Jyotika Athavale. Jyotika Athavale is a senior technical leader in automotive functional safety at NVIDIA, driving capability development, safety architectures and methodologies, system safety engineering activities, and pathfinding for safety critical markets such as autonomous driving and avionics. Prior to NVIDIA, Jyotika was principal engineer, a director level position at Intel Corporation, where she led functional safety platform architecture for automotive and avionics use cases and drove corporate-wide methodologies for radiation effects, modeling, and product qualification across market segments. She is a senior member of IEEE and an influencer in emerging technologies and standardization initiatives. She was awarded the IEEE Computer Society Golden Core Award in 2022. Currently, an elected member of the Computer Society Board of Governors and Executive Committee, Jyotika also serves as a 2022 Secretary and Distinguished Visitor of the Computer Society. She chairs the IEEE P2851 standard on functional safety interoperability. Jyotika is a core member of the IEEE Computer Society Functional Safety Standards Committee, Design Automation Standards Committee, and Diversity and Inclusion Committee. In addition, she represents the Computer Society at the IEEE USA AI Policy, IEEE SA Industry Connected Group on Mobility as Service, related standardization activities. She is also on the IEEE Women in Engineering Committee and the IEEE Systems Council. Jyotika also serves on various technical conference committees and has authored patents and technical publications in various conferences and journals. So today's talk is safety for autonomous vehicles, addressing interoperability and dependability challenges with IEEE P2851. The IEEE P2851 standard defines a dependability lifecycle of products with focus on interoperable activities related to functional safety and its interaction with reliability, cybersecurity, safety of the intended functionality, popularly abbreviated as SOTIF, and real time. The standard also describes methods, description languages, data models, and databases that have been identified as necessary or critical to enable the exchange interoperability of data across all steps of the lifecycle, encompassing activities executed at IP, SOC, system, and item levels in a technology-independent way across application domains such as automotive, industrial, medical, and avionics safety critical systems. Jyotika Athavale, today's speaker, is the chair of the working group on the standard and will provide more insights into the topic. So let us welcome Jyotika. Okay, over to you. Oh, yeah.
Thank you so much, Vishnu, for the introduction. And before I begin my talk, I just wanted to extend my recognition to Dr. Vishnu for organizing this event and also, inviting all of you here, including myself, as the chair of the Silicon Valley chapter. He's actively involved in a lot of activities, organizing several events for the Silicon Valley community, and for that, I'm very grateful. And so I just wanted to extend my appreciation to Dr. Vishnu. Personally, I also, I'm fairly new to the Bay Area, so I just moved here last summer. And so it's really great to see this activity here in the community and to see this active involvement in the computer society. So I'm looking forward to getting more involved in the local community and the activities here. And I hope to work closely with all of you as well. So thanks again for being here and for participating in this event and in the presentations. With respect to the presentation, so I have a few slides here that talk about the work that we're doing in standardization in IEEE. But I'd like to have it as more of an interactive session. So feel free to stop me at any point, questions and comments, and we can go through this just as a conversation. So a little bit about P2851, and Dr. Vishnu already gave us an introduction. This is a standard on functional safety interoperability for the data format within the dependability lifecycle. P2851 was kicked off as a working group in early 2020. Some of you here, Shrenik's already also was part of the working group. And others, there's a lot of members across the globe that are part of P2851. I'll talk about the membership and all of the folks who are involved in this standard. So it's about 2.5 years currently in development, and we are working on the first draft of the base standard that is currently close to being final. So with that, we'll walk through the slides, and I'll talk a little bit about what we're doing. Can everyone hear me okay? Is this okay? Great. Right, so I think it's stuck there. Thanks, Vishnu. Perfect, thank you. All right, so a little bit about IEEE and for safety standards and what we are doing here. So for functional safety, there are several standards development organizations, or SDOs as we call them, who are involved in standardization work. You're probably more familiar with ISO and IEC and UL as being some of those SDOs that are actively been developing standards for functional safety over the years. For those of you working on automotive, are probably familiar with the ISO 26262, for example, or the IEC 61508 for industrial systems, the DO 254, DO 178C for avionics, that's part of the RTCA SDO, and then there's the UL 4600, etc. So with respect to functional safety, the work in IEEE is fairly new in comparison to those SDOs. This slide here talks about where do we fit in that space. So we have what we call the foundational standards. These are the domain-specific standards or the governing standards for each application domain. So for example, for automotive, we have the ISO 26262, the UL 4600. There's a standard for SOTIF that was recently developed as well. There's for industrial, we have the IEC 61508 standard, which is also the mother of all of the safety standards across the application domains. For avionics, as we said, we have the DO 254 and DO 178C. Now, with respect to the work that we are doing in IEEE, it's considered more of supporting standards, so supporting the standardization work in functional safety, not intended to replace what is being done by each of these, foundational or governing SDOs, but to support the existing standards that are already have already been developed in that space. I know one of the questions I got just earlier before we started the session was there's an explosion of standards happening right now. There's just so many standards being developed in safety and cybersecurity and AI in general, and also in the dependability space as a whole. And how do we connect all of these different standards and how do they fit within each other? So there's some work in that area also being led by IEEE. And I'll talk later on this, in the slides, but we recently formed a kind of a steering committee called the Functional Safety Standards Committee that is covering the entire dependability space. It's covering functional safety and its interactions with cybersecurity, with reliability, availability, maintainability, as well as with time determinism. And within that umbrella committee of the Functional Safety Standards Committee, there is work happening with respect to, for example, developing a white paper that is a mind map connecting all of these different standards that are in development and how they fit within each other. So for example, different standards across the application domains for safety, for reliability, for cybersecurity, etc. So that's some of the work. So P2851 is one of those supporting standards that is being being developed right now, and it's more of a family of standards, as I'll explain, that is providing this role for functional safety interoperability, connecting the various domains, and really solving the interoperability problem in various different ways that we'll talk about on the next slide. Feel free to stop me if there's any question or comment at any point as well. Just raise your hand and we'll take the mic over to you. So the problem statement, so what are we trying to address with P2851? So there's various problems described here in the bullets here. This is kind of the landscape or the problem statement that was at hand when we kicked off this working group. So the first thing there is the lack of common methodologies, description languages, or databases to deliver the results of the safety analysis across the supply chain and across domains. So this is the interoperability problem statement for the safety engineering team across the value chain. So if you look at IP developers, SOC vendors, tier ones and OEMs, across that, we saw this common problem statement with respect to data exchange. So, taking, for example, safety analysis at one of those levels in the value chain and then integrating them up the chain, up to the item level is difficult because there isn't a common framework, a common template, a common methodology, or a data model, for example, to do that safety engineering work or to do that safety analysis and verification work. So that's one example of interoperability, is across those different levels of the value chain. The other kind of interoperability problem statement was, doing the work for one application domain like automotive, and then using that safety engineering work or work products, reusing them for another domain like industrial or medical or avionics. So right now there is a lot of focus on, how we can leverage that work, work done that's done for ISO 26262, for example, leverage it for industrial or avionics. But how do you do that without a common framework or a common methodology or description language? So that's the other kind of interoperability. The third kind of interoperability was, well, we're doing this work for safety, but then how does that impact the adjacent technology? So what is, the implication to real time or to cybersecurity or to reliability and vice versa? And how do you take into account those interactions and develop a holistic solution, a holistic way of doing your engineering such that you are addressing those trade-offs between the different technologies? So that was the other kind of interoperability problem statement. So starting with that landscape, there was this need to urgently find a solution to address all of these different topics and to accelerate the safety engineering process while considering all of these different trade-offs and reducing risks and costs. So the objective of P2851, and when we started out, was to focus specifically on the format for data exchange, to kind of streamline this data exchange across all these different levels, across application domains, across technologies, and to do that in a consistent way, right? So we had, this impacts tools for doing the safety engineering work. This impacts the safety engineering team, say, in your IP, SOC companies. And this also impacts the tier ones and OEM. So the goal was to provide structures and directions for the seamless exchange of information to account for interoperability, to solve the interoperability problem between activities at the same or different level of abstraction. So here's a little bit about who is part of the P2851 standardization group currently. And so we have several entities, about 30 companies representing EDA vendors. There's IC providers, there's tier ones and OEMs. So over 70 active individuals currently part of the P2851 working group. And then, at the bottom there are the working group officers. So for each working group, in IEEE SA, we have a chair, a vice chair, the secretary, as you can see here, Neil Maurer from Qualcomm is the vice chair of P2851, Merav Nitsan from Synopsys serves as secretary, and then we have Jonathan Goldberg, who is the program manager for P2851. The companies here are, some of them are advanced members of IEEE SA, which means they are voting members and they can influence the standard or contribute to the content in the standard. Some of them are basic members, which means that they act as observers, but they are non-voting. So they can monitor the activity in the standard, the development, but they cannot contribute to the content. So, there was some question that came up earlier in the session as well as to how do you participate? How can I join a standards committee or a standards working group? There's different ways you can participate. Some of the working groups, such as P2851, is an entity-based working group, which means your entity or your company needs to be a member of the working group, and you can be either an advanced member or a basic member to join. There are other working groups. For example, there's the P1228 working group that is individual based. So your company doesn't have to be a member, but you can join as an individual, just being an IEEE member, and you can participate in the development of the standard. Similarly, there are committees, so like the Functional Safety Standards Committee, where the P2851 reports into, is also individual based. So if you're interested in joining standardization work, there's various ways in which you can participate, either in one of the working groups, in a study group, you can join a committee. There's work happening where, before you have a working group kicked off, before you have a project authorization request to drive a new standard, you have these brainstorming study groups where you're discussing various problem statements, you're discussing potential topics that could become a standard in the future. So kind of that incubation period for the standard. And so, those are different ways in which you can join these efforts. So, various ways to participate. Also, besides the Functional Safety Standards Committee, there's AI Standards Committee, there's a Design Automation Standards Committee, there's Cybersecurity Standards Committee. So there's various in the dependability space. There's a lot of committees and topics to contribute to. In fact, the P2851 working group used to report into the Design Automation Standards Committee just because there is such a close link between the tools and the EDA folks. And so we still have this dotted line relationship with the DASC, even though we now have a Functional Safety Standards Committee that's kicked off. So any questions on the committees or, you know, how to participate or join or contribute?
I actually have a question. Looks like if we look at the profile of the participants in your working group, it's mostly semiconductor industry, right?
So there's a lot of, you're right, Mr. There's a lot of semiconductor companies that are currently participating. There are some EDA folks there. So we have, for example, Synopsys, Cadence, Siemens EDA that are part of it. We are a little bit light on the tier one in OEM. We have Ford, that's a representative as well. And then on a case-by-case basis, or, you know, at certain times in the development, we reach out to some of the tier ones and OEMs to get their feedback. So for example, right now we are organizing some workshops where we are inviting those representatives from some of the major OEMs to get their feedback. We also have liaisons with other standardization groups, which have other, you know, spectrum of participants. So we try to get feedback that way. So yeah, so
Are there any efforts to involve, say, autonomous driving car companies like Tesla?
yeah, so those are the OEMs that I was mentioning. So, you know, so currently, you know, there is the working group 8, which is the ISO committee, which is the, you know, the international body that has a lot of those OEMs that are part of it. And so we occasionally pull them in via these workshops, as I mentioned, that we, you know, we are currently have these scheduled for end of September, early October. And those are with these major car manufacturers or OEMs where we will, you know, solicit their input, but also for getting them to see the value in the work that we are doing and get them to engage more, you know, actively with our working group. So that's one way. The other is there's other ISO and IEC committees where we have some of the OEMs participate and we report out there, you know, periodically, like once a month or so, and get feedback that way. So there's different channels to communicate or engage with those, you know, car companies.
And how much of your standard is relevant to the autonomous vehicles side of things?
Yeah, it's a great question. So a lot of the people who are currently participating are working on automotive. So, you know, it's a little bit skewed on automotive, although the work that we are doing applies across application domains. So it applies to also to industrial, medical, and avionics safety critical systems. In the future, we may also like expand that to railways, you know, other transportation systems as well. So the first base standard that we're working on is application domain agnostic. So it's even though a lot of it is a lot of the content has been created referencing the ISO 26262, which is the automotive safety standard. We have been looking at the requirements in the other domains as well. And so that first base standard is industry agnostic.
So is there any vehicle-to-vehicle communication part of it in the standard?
Not in the scope of P2851. So the V2X is not in scope of that. We are looking primarily at dependability in scope. So what we are doing is, and I'll talk about that on the next few slides, is a dependability life cycle. So looking at functional safety and its interactions with cybersecurity, so reliability, availability, maintainability, and real time, but not the V2X is not part of it. And then we are looking at it across levels, so IP, SOC, system, and item levels.
No, I think if I could just clarify.
Sure.
I think there is a different standard group which is looking at B2X, B2B. Yeah, vehicle to infrastructure is the way. Yeah, vehicle to vehicle. There are some other standards, and there has been, at least recently, I think some of the standards got taken away. on B2B, because for 20 years the bandwidth was allocated and the industry did not do anything, so federal government, the FCC or someone who is allocating the bandwidth. So I don't know how it is going to get solved by the industry or the government. That's a different discussion. A little bit outside of that topic. Just general interest, I think there are different standards. There is this, like,
Thanks, Shrenik. Yeah, for that. Yeah, absolutely. And also within IEEE, if there's work happening in B2X, I'll be happy to point you to that, Vishnu.
So you said that, what role does the government play in the standard? Do you ever access?
Yes, so the regulatory part for sure. Yeah, so in the case of IEEE SA, there's a whole approval process that goes into, the draft getting to a standard phase. So I can go through that. It's not part of my slides today, but basically after the working group finalizes the content, and then it goes through all of the different committee reviews within IEEE SA. It also goes through a public review process and a balloting process. And that's where, we get feedback from the other entities and agencies outside of IEEE on the content. So there's an entire life cycle, so to speak, before it becomes a standard, including the feedback from all of the different entities and agencies outside of IEEE. And maybe we can do a separate talk as well, where I can, describe what that life cycle looks like. But for sure, I think there is that part where, we have the balloting for it to, before we finalize the content, and before the standard is approved. But then also with respect to adoption, that's something that is done on an entity by entity basis on whether the standard gets adopted, whether they choose to comply with it or not. So.
Okay, thanks, Jyotika. And I believe there's a question on chat window as well.
Awesome.
So the question is basically similar to what I asked, but they're also curious to know if Apple is also, why Apple is not included on your list.
So it's, as I said, it's a good question, but we open this working group to any entity is welcome to join. They have to be an IEEE SA member to join. Some entities are members, they are, and of course there's a membership fee associated with being an advanced member. So some entities choose not to be an IEEE SA member and they, don't join the working group. IEEE SA recently changed their membership rules. So now to be an observer or to have that basic membership, it's free. So, you can't vote on the standard, you can't influence the content, but you can still, participate and monitor the work that's been happening. So Apple is not, hasn't joined us, or I'm not aware of them being part of other IEEE SA working groups on safety either. So it's a company by company decision on whether we want to participate or not. But I think we have a lot of the other semiconductor folks there, right? So like Intel, NVIDIA, Qualcomm, AMD, others are all, part of the standards group. Sure.
Any other questions?
I'd like to make a comment on that. I think one of the things is that in 2020, when the P2851 working started, one of the decisions made was like use the entity method instead of the division method. Because the entity method forced that it had to be an entity join.
Right. Right.
The division method allows anybody to join, including academic and other people. A
Sure.
lot of people, including myself, was actually excluded.
Mm.
Wasn't able to join participate. Therefore, that was actually a big disappointment. And I believe that a lot of companies, for example, like Apple, they do have people attending other working groups, participating today. They weren't joining the entity base, not just yours, but also including, for example, like VR working groups.
Yeah.
As they all choose for entity based. I think this is something that maybe I really need to be considered.
Yeah, it's a good input. And there's actually a way to work around that. So you're absolutely right. Some of the working groups are entity-based only, and some of them are individual. But I know some of the representatives, for example, if you'd like to contribute or you'd like to influence the standard, you can join the FSSC. So, the P2851 reports into the FSSC, which is the Functional Safety Standards Committee. And that committee meets, monthly, and that's individual based. So you can join the FSSC where we report out, the P2851 reports out and on the progress and, request feedback from that, wider committee. So there's a way to get to participate, even if not directly in the working group. But I absolutely agree. I mean, there is the working group at the working group level, certain working groups are entity based and certain are individual based. Now there's another one on software safety, the P1228, that is individual based. So, anyone can join, even if your entity is not a member. So it's just, the way IEEE SA has it organized, but, we can talk offline as well and, figure out how best you can participate. If you'd like to participate, there's a way to do it. So I just want to make sure that we're not being restrictive from that standpoint.
Any other questions? So since you want to make it interactive, I have one more question.
Sure.
So, just curious, how much support do you get from your employer, like NVIDIA? How much support do you get from your management?
Yeah, it's a great question. So in NVIDIA, we do have, a focused initiative on standardization. So, not just for IEEE, but there's also active involvement by NVIDIA in the other SDOs. So for example, in ISO, in IEC, in UL as well. So it is definitely part of our scope and work. So for example, the work that I do in NVIDIA includes standardization as part of my role. In addition to the other work, which is mainly pathfinding, functional safety architecture related for automotive and for avionics. But definitely standardization, there is active involvement and leadership by NVIDIA, driving a lot of those committees across the different SDOs. Prior to my joining NVIDIA, which I've only been there a year and a half, I was at Intel, and similarly at Intel as well, there was active involvement and participation. Intel, for example, was leading the IEEE P2846, which is the other functional safety standard led by IEEE. And so, active focused involvement and support in standardization there as well. So a lot of these other companies that you see here also who are actively participating in the standard are doing it on behalf of their company. And so with that support. Sure. All right, so moving on here. And I think I lost the mouse again. Sorry about that. All right. So this is a question we get quite a bit as to, we touched upon it a little bit in the beginning, but how does P2851 fit in with respect to all of these other standards, because there's so many of the functional safety standards out there now. So we talked about this interoperability or chaos with respect to the data exchange across the different application domains. So what you see in the bubbles there and the three circles are the three different application domains. So the first one is automotive, where we have the ISO 26262, the ISO 21448, and the UL 4600. The second one there is the industrial, which is industrial machinery with the IEC 61508 and the ISO 13849. And the third is for avionics, which is the DO 254, DO 178. So those are the mainstream standards for safety for a given application domain for these three domains. And they have the key requirements for the safety engineers to execute, go through the life cycle and develop the work products, demonstrate compliance to those requirements. So Where P2851 fits in there is across those standards. So the intent of P2851 is not to replace or change any of the requirements within those governing standards, but to enable the exchange of data by providing that framework, by providing a methodology or that data model to facilitate that data exchange across those domains. So from that standpoint, we serve as the glue. So there you see that green, rectangle spanning across, where P2851 is serving as, that interoperable platform to enable the data exchange across the different application domains. So that's one kind of interoperability. The second kind of interoperability, as we mentioned, is within a given application domain. So if you look within one of those circles, as you traverse the levels, going from IP to SOC to system to item, it's that interoperability across the levels of the value chain. And then the third one we talked about is between the dependable attributes, right? So typically, or I guess traditionally, the way we've been doing our engineering work is we have a set of requirements for safety and we go ahead and execute to that. Then we have a set of requirements for cybersecurity and we go ahead and execute to that life cycle. And then we have the reliability team looking at all of the reliability architecture and working on that. But these teams are not really working with each other and considering the implication and the trade-offs of those requirements and the mitigations that need to be implemented for each of those requirements. So that is where the dependability comes in. And looking at that holistic architecture such that we consider those trade-offs to develop a common technology architecture considering all of those technologies. So any questions here before we move on? Yes. Mm-hmm. Mm-hmm. Yeah, absolutely. It's a great question. And if you don't mind, which industries were those? Yeah, no, it's a good question. So I can give you an example for safety. So when you look at safety critical systems, so for example, when I was in my previous role at Intel as well, and I worked on avionics, and I'm also exploring that currently in NVIDIA, we look at how we can reuse the safety engineering work from ISO 26262 and leverage that for compliance to the avionics safety standards, like the DO standards. And the reason is because the DO standards are written about 2001. So, like 20 years ago when they were only single core processors, and things have changed a lot since then. ISO 26262 takes into account the implication of multi-core, and covers the life cycle with all of the safety engineering activities and describes how to consider those tasks. So there's work being done to reuse the work. Some of the work is already published. There's also work being done by FAA and in terms of white papers to formalize that reuse. Similarly, there's work also happening on, leveraging the automotive safety engineering work and applying it to industrial, systems. And all that's also being done by a separate working group, a separate standardization working group. So there's definitely that, formalization of that reuse happening. What P2851 is doing is strictly related to data format exchange, looking at how to exchange that data across those domains in terms of description languages, data models, and methodologies, right? And providing how do we provide those frameworks and those methodologies to facilitate that data exchange. Sure. Okay, so moving on. So last June, the P2851 working group published a white paper. That white paper is available on IEEE Explore, and I can send out a link as well if anyone's interested. That white paper introduced, some of this work, preliminary work that we were doing, and also introduced this notion of a dependability life cycle. So that's what's described here on this slide. And so what you see here in the green boxes is one example of how those trade-offs are being considered, across the different technologies. So looking at functional requirements, then looking at, what is the implication from a performance standpoint, looking at the trade-offs with reliability, functional safety, and SOTIF, and cybersecurity, and doing that iteration to understand the trade-offs, between these different technologies as we go through the safety engineering process, and what do we need to consider such that we are not violating a requirement in an adjacent technology while implementing, the functional safety life cycle. So I just wanted to clarify here that when we talk about the dependability life cycle, this is as seen from the functional safety lens. So this is strictly looking at how do I execute my functional safety engineering process while considering implications from these other technologies. It doesn't refer to dependability as a whole, meaning we're not looking at, the relationship or the implications of cybersecurity and reliability or real-time and cybersecurity, but we're just looking at functional safety as the core, and then the implication of functional safety with all of these other adjacent domains. So that's how we look at dependability, or that's the view, is from a functional safety standpoint, and what do we need to address or account for as we do our safety engineering work. On the right there is the V model, and this is the V model from the ISO 26262. We used that as a baseline or a reference when we did this work on defining the dependability life cycle, because we think it represents well the safety engineering process with, the design activities on the left side of the V and the verification activities on the right side of the V. And it also goes through all of the different levels. So, you have the IP SOC system and item. So it describes all of the activities that need to be executed at each phase of the development life cycle, spanning from concept to requirements definition, architecture, design, verification, validation, and then also the evaluation, production, post-production, right? So looking at all of the activities and then looking at intra and inter-level interfaces through those levels. And as we go through those activities, we then list out which are the activities where we need to consider interoperability. So say, is it the safety analysis? Is it the FMEDA work? Is it the modeling of the vulnerability factors? Is it your definition of the safety plan, the safety manual? Is it some work that you're doing in post-production on telemetry? So looking at each activity and then looking at the work products, the inputs and outputs, and where are those points or those nodes where interoperability is an issue and where we need to address it. So that's kind of the thought process behind the work that we've been doing. And then since that white paper, which is where we have these charts from, we now have a more mature base standard, which is now being finalized and which we plan to release soon. And I'll talk about that roadmap here in a few slides. But any questions before we move on the slide? So here's some examples of those needs and requirements. So P2851 working group, when we kicked off, we split up into 6 subgroups. And so each subgroup looked at a specific area. So for example, we had automotive FUSA as one subgroup. We had AI FUSA as another subgroup. We had SOTIF, we had safety, security, and then we have industrial and avionics. And so each of these subgroups went
Okay, we have the participants, so we didn't lose any.
Great,
So
thanks so much.
that's- But I guess I will have to initiate the recording is in progress and live stream also in progress. So we are good. Yeah,
Great,
thanks.
perfect. Thank
Was
you.
the one?
The next one, yeah. Okay, let's see. We talked about the needs and requirements here. And so what we have here is just an example. So the subgroups that were put together collected a list of about 108 needs. And those are the needs that are included in the white paper that we published last June. Now there's a subset of those needs included here on this table, just as examples to give you a flavor of the kinds of topics that we identified where we need to consider interoperability. And then these needs are then described in terms of requirements in our base standard. So some of those, for example, where you see the description language, that refers to like a framework or data model or a template for that specific topic or that work product, right? So for example, we have safety plan, safety case, confirmation measures, external measures, assumptions of use, and then base failure rate estimation. Then we have needs for methodologies or ME, and there's some examples of those there, like BASL decomposition, vulnerability factor modeling, non-deterministic behavior analysis, etc. And then databases, which are mainly like a list of parameters or values. So in this case, like use environment, like what are the parameters you need to consider, like temperature, humidity, voltage, etc. Vulnerability factors, what are the different kinds, like the ABF, BVF, TVF, AI training data sets, list of safety mechanisms at different levels, etc. So those are the kinds of some of the examples, but then, going activity by activity, we collected about 108 of those in all across the different application domains. So that's included in the white paper. And then here's the FSSC that we talked about earlier, the Functional Safety Standards Committee that, is the overall container for all of the functional safety standards, within IEEE that are related to safety. It covers architectures, methodologies, and tools, addressing functional safety and other safety-related aspects of intended functionality. It spans across the different application domains, so it includes automotive, industrial, avionics, as well as high-performance computing. And it also covers that dependability scope, which is also part of P2851, including safety, cybersecurity, reliability, real-time, etc. And then finally, the roadmap. So, this is our current timeline for P2851. As I mentioned earlier, P2851 is a family of standards, which means we have our base standard swim lane, so to speak, and then we'll have the dot standards or the derivative standards that will follow. Now for the base standard, we are currently on the first revision of the base standard, and that is expected to be published by middle of next year or by around June of next year. Right now, the working group is finalizing the draft. And then, we expect in October, it'll get into the public review balloting phase of the life cycle of the standardization work. By end of 2023, what do we plan to deliver? So we want to kick off the next revision of the base standard, which is the revision 1. So the first revision, which is revision 0 that we're working on right now, is this domain agnostic dependability lifecycle with all of the needs mapped to each phase of the dependability lifecycle. What we plan to do in revision 1 is have the domain specific life cycles. So, what are the specific requirements for automotive only that don't apply to, the other domains? What are the specific requirements for, say, medical, industrial, or avionics. So it's diving into that lower level detail. Whereas right now for the Rev 0, we have the, the 1,000-foot view or the generic domain agnostic view that envelopes all those application domains. And then we get into the details that are domain specific in that revision 1. And then in the DOT standards that will follow is when we plan to implement some of those needs. So for example, the FMEDA data model, or the methodology to model vulnerability factors, the template for safety case or safety manual. So that implementation of those specific needs is planned to happen in the DOT standards. And that's where we also plan to fold in the work that's being done by the Accelera Functional Safety Working Group. So, Accelera kicked off a functional safety working group around the same time as we did in January of 2020. And so they have this parallel work that's happening that will be released as part of P2851 and will be folded into our DOT standards. So that's how we plan to continue the work. We do not plan to implement all of the needs because we do have like I said, 108 or so. We have a priority assigned to each need. And so it's those key needs that will be implemented. That priority is one that we are looking for the car companies, so for example, the OEMs and tier ones, to help us identify which are those showstopper topics that we need to focus on. And so in these workshops that we organized towards the end of September is when we will be, discussing those needs with them and asking for their input on the priority to guide that priority and for that future work. So that was my last slide. We can open it up for any other questions in the room here. Yes.
Data safety issues related to drones.
Yes. Yes, absolutely. So the drones is a part of the work that we are doing for avionics. So that scope covers, the commercial drones, the passenger drones, as well as, traditional aircraft, commercial, military, also covers some of the space related aspects as well. So all of that is covered under the avionics. Now we also engage very closely with the DO 254 user group. So we have a liaison with them, in an informal liaison. And then there's work happening in the SAE G34 on AI in aviation, where they cover some of those aspects as well, like for example, for drones. So some of those drone companies are very active in the SAE G34, which we also participate in. So for sure that is in scope, and that we are considering the DO standards and the SAE standards to be the governing standards there for drone safety. But there's new work happening in the standardization space, and for avionics, it's primarily RTCA and ASTM that drive those standards. So we try to monitor and to participate or link with those, so that we are including our work in scope of their effort. There's as I was mentioning, there's a white paper that we are planning to release, or that's already in progress by FSSC, with this mind map of all of these different functional safety standards by domain, so that we know which ones apply to which application, and that we are considering those in scope. That's a good question though. Thanks. Yes.
What about robotics?
So robotics is covered by that industrial, robotics.
Super robotic.
You're right. So currently, we do not have that in scope of the P2851, but currently the ones that we have in scope is the IEC 61508 and the one on machinery. But anything that's new in development that's not released yet is not part of the P2851 scope yet. But we could expand scope later in the future as those standards are released and published. So Good question. Yes. Mhm.
Thank you, great presentation. I was curious when you mentioned about the associate vendor,
Mhm.
as environment, early stage, has any associate vendor started think on this standard and maybe they have changed the part of the data formula has to be changed to the standard, or it seems that they have the IO form, the standard will take care of that.
So there are some, so you're right there. I mean, in terms of the scope, so we do not just not focus on hardware, but includes the firmware and the software, etc. Um, I guess in terms of the requirements, the implementation of that will be done, by each entity to make sure that they are taking into account these interoperable requirements when they're going through their engineering work. But that implementation could be different from entity to entity. Now, we will provide some guidelines when we have the DOT standards in terms of implementation. This is a suggested format for data exchange, for methodology or description language, etc. But the implementation of it could be specific to a given company. So for, like firmware, like you mentioned, it could be company specific as to how they want to consider it and do it based on that guideline. In some cases, there are already implementations available, in which case we would probably use those and create an example using those references. So for example, some of the description languages like the SysML and UML, etc., already exist. We may leverage those rather than inventing something of our own. But yeah, for sure, that will need to be considered through the engineering process for hardware, firmware, and software. We also have a chapter in the P2851. One of the dependability lifecycle phases is the hardware software co-design, where we consider some of those interactions and what are the requirements that you need to consider in that software hardware co-design.
Because the process by itself, right?
Yeah.
And embedding within the architecture and the fabrication, right? With outside, that's fine. You cannot do that.
Mhm. Sure, thank you. Yeah, no, it's a great question. So if you mean like verification and testing in the safety engineering process, yeah, absolutely, that is in scope. And so, we cover the entire life cycle in scope. In the dependability life cycle, we do have a chapter that covers the analysis and verification, and then, the testing, validation, the dependability evaluation, etc. So it's all of those different phases of development that are in scope of the interoperability work. And in the way the standard is structured is we have a chapter representing each phase of the dependability life cycle, starting from product definition, going through the requirements capture, the architecture, etc., all the way through verification, test, etc. So yeah, definitely in scope.
One last question from Thomas.
Sure.
I was curious, is there any monitoring involved in that? Is there a budget for those standards?
You mean by IEEE?
IEEE or company, and a lot of folks are interested in becoming members.
Right.
So,
Yes. So in terms of membership, for sure, there is the monetary aspect. And as I was explaining earlier, there's different tiers of membership. So to be an advanced member of entity-based working group, there is an annual fee that the company has to pay IEEE SA to keep that membership active. And that advanced membership allows the members to participate in the development, influence the development, contribute to the standard, etc. The basic membership is now free, which means that to be an observer, a non-voting member, you can join, you can participate in the plenary, but you can't have access to the materials. To have access to the documents, you need to be an advanced member. On some of the working groups which are individual based, it's free. So you don't really have to be, have that advanced membership. It's just that certain standardization working groups are entity based and certain are individual based. So depending on where you want to participate, you could decide what level, your company would like to participate in.
Like for instance, can the VTS chapter who's sponsoring the students be able to join the standards member?
So there are some standards that are co-sponsored by say FSSC and the VTS, right? So for example, the P2846 is one example where VTS was the sponsor and the IEEE Computer Society FSSC was a co-sponsor. So there is a lot of that cross linkage or working together. Like for example, for P2851, we have two committees, the DASC and the FSSC. So for sure, they can. Now, the fee that I was mentioning was applicable to the participants of the working group, meaning in terms of the entity or the company, that they represent. The society is more of a sponsor for the working group. And so they are the ones who will, where the committees and the working groups will report into and, be part of that organization.
So a chapter can also be one of the.
No.
So that's what the society was.
I think society can sponsor the activity, but the participants are different. So either
Yeah.
individual representing themselves, they are representing.
Correct.
And the company, then for just to pick it's somewhere about $10,000 for corporate membership. And it goes by the size of the company. So depending on your revenue, IEEE has different levels. You can find it on IEEE corporate standard group. You can Google it and find it, but somewhere it's $5,000 is the minimum, 10,000 to $5 billion and all. What you are asking is very minimum membership fee. $10,000 for a company with $5 billion revenue. And more of the engineering arm which you're going to put in is more value. So if you're serious about it, you will spend that engineering effort to develop the standard and influence and just. So the membership fee is, and one of the thing is to move away from individual ones is you don't want to be overloaded that a large company puts a lot of its engineers into it and tries to influence the standard because you can have a lot of contributors in a company, but versus a smaller company and an associate member also has the equal level playing field by having one company, one vote. So there are pros and cons to it, and if you want to move sometime fast, large company you may not be able to agree. So they can just drag on. And so it might be that somehow you manage that you have only one vote. And for a large company, you will have only one vote. The person assigned will vote on behalf of the company. They may internally disagree. They will have to think about it at a committee level. You want to have one vote. And that helps you the standard to the company. Because a lot of times the criticism is standard takes too long to get. And a fast moving industry, people then just go to the standard. So I think it's all good.
Yeah, no. No, thanks, Shrenik, for that clarification. By the way, there's other SDOs that have a similar model. So for example, RTCA has a similar model where, the company has to pay based on their revenue and, the membership fee is based on that level. So this, the standardization membership is driven by IEEE SA. So, they are the overall organization that manages all of the standardization activities within IEEE. It's the Standards Association.
Okay, I think
We're out of time.
yeah, we're running out of time. So
Thanks, everyone. Thanks, Vishnu. And thanks, everyone, for joining on the great discussion. Really appreciate it. And thanks for participating.
And a small token of appreciation
Oh,
from our
Thank you.
chapter.
Thank you so much.
Thank you. Thanks for coming. Very insightful talk.
I appreciate it.
So we end the event here, but before we end, sincere thanks. Yeah. Sincere thanks to my student Milind, first of all. He has been helping all 4 days in various ways. Thanks to my student Aishwarya Shankar. She has been volunteering for all 4 days to the conference. And thanks to the speakers, today's speakers, Shubhi Asthana and Jyotika Athavale. It was really very insightful. All of us really gained a lot of from your talks. And hopefully we'll see you soon again, right? Thank you all. And let's break now. Thanks.